we met in person. That was really nice. You were giving a talk at ODSC West. It
Mhm.
was about bias. And can you fill us in more about what you covered in your talk?
Yeah, yeah. So the title of the talk was kind of grabby. It's bias is good. Arguments for automated labeling.
Right.
So like kind of the core argument, so to speak, is that the word bias is overloaded in data science. Not only
Right.
does it mean societal impact of models that are trained based on historical biases and that sort of thing,
Mhm.
historical like stereotypes and stuff like that. It also means um, like it's got the connotation of like weights and biases, a constant
Yeah,
or
yeah,
a
yeah.
vector factor. So there are like several different uses of this term, and there's sort of a middle ground term as well, which is go ahead.
Oh, yeah. I was just going to say yeah. And from a technical perspective, like in that sense, bias isn't bad. Like bias is just a part of like in a neural network, you have weight parameters, you have bias parameters, or you could even think of, you could describe the y-intercept offset in a simple regression model as the bias.
Exactly.
And like,
Yeah,
I mean, and that's
100%.
completely harmless. It's like if you don't, I like the idea of some like really naive data scientists just starting out with their first regression model or the first neural network or something, and they're like, "Oh, should remove the bias term,"
Yeah. Yeah,
and
yeah.
then just never having a model that fits the data very well.
Yeah, yeah. So like kind of our whole thing was that it's important to lens the word bias with all of these things, but it's not all that helpful to have like a super overloaded term that's used like pretty widely across machine
Yeah,
learning. So we
you were
offered
even you were going to give us a third one but then I spoke over you. So you were talking.
oh
So we've
yeah,
got
yeah. I mean
yeah.
the sorry, the first one is like societal impact stuff, like model trained on stereotypes, essentially. The
Mhm.
second was your bias factor, your weights and bias, your bias parameter, really. Um,
Mhm.
the third is sort of like this middle ground where you actually are biasing a model towards like a true representation of reality. So it's still
Mhm.
sort of an up level
Mhm.
of like the bias concept in terms of like a bias parameter, but it has no negative connotation to it. So our whole
Right.
thing, at least at the beginning, was like we should just define two types of bias real quick, just so that we have like a basis to talk about. So um, basically, we proposed like bias is just an act of shifting the effect of a model to one side or another, or to a
Mhm.
specific area. So like limiting the space within which a model has acceptable outputs. So an
Mhm.
example of this is like I want to train a model to predict spam. I could bias it towards predicting spam correctly. I could bias it by saying like if the word Viagra shows up, it's very likely spam, and that's probably true to some extent. But it's still very important for us to be able to talk about the societal impact of bias. So we propose another terminology, which is degenerative bias, where in fact, when you bias a model using these outdated stereotypes or whatever they happen to be, your personal biases, and you bring them to the table, what you're doing is you're actually biasing the model away from an accurate representation of reality. And
Mhm.
so it's important that we lens the discussion with those two things. And sort of the core point of that whole talk is basically to go on to say that the way supervised machine learning has evolved over time has made supervised machine learning very reliant on hand labeled data, which is where which is one of like many different sources of this bias can creep in, specifically degenerative bias. You could have
Mhm.
hand labelers like who bring their own biases to the table. You've got the way you're sampling data that could be biased inherently, the way you're stratifying it. All sorts of things can affect the way your model's performing. These days, most of the time, I'm not going to say all the time, but most of the time, your model's not biased because you trained an inherently biased like architecture. It's
Right.
usually because your data is biased in some way, degeneratively biased.
Right.
So our whole argument was, look, we can't really get away from labeling. So you have to label data, but maybe there's a better way to be more explicit about the biases we're checking in. And if you're explicit about them, then it's possible to go back and change them. So now the question is, what techniques do we have to be able to do that sort of thing? And weakly supervised learning is one of them. Active learning is another one of them. I had a whole slide of just like various techniques and how they kind of play together. But it was meant to just be like look, you can't really get away from bias. Bias, the whole point of labeling is to bias a model. But what you do want to do is limit the amount of degenerative bias you're introducing. And in order to do that, it has to be explicit. It can't be implicit. So yeah, that was sort of the core of the talk.